Hello, everyone. Good morning, and welcome back to another episode from Scale Up Thursday series. My name is Rashmita, and I'm the event planner for Microsoft Reactor India. Today, I'm here joined by our very own host, Vinayak and Vivek, and of course, our special guest speaker, Dr. Rimjhim. But before we start today's session, I would request you all to read our code of conduct. Let me bring that in for you. We are all here to learn together, so please be respectful of other people's views, understanding of differences, being kind and considerate in the way you engage. The chat section is open throughout, and we do encourage you all to participate. Our speaker will answer all your questions during the session, so please feel free to drop all your questions in the chat section. With this, I would now like to thank you all once again and enjoy the session. Over to you, Vivek. Let me bring Vivek in first.
Hey Rashmita,
Hello, Vivek. Hi.
thank you for this welcome, and folks, welcome to the Scale Up Thursday show. And I'm Vivek, senior cloud advocate from Microsoft, and I have Vinayak with me, who is going to co-host. So I just want to welcome Vinayak here. Hello, Vinayak. Good morning.
Hi everyone. Hi, I'm Vinayak Hegde. I'm the CTO in Lessons at Microsoft for Startups, and I help startups, choose their tech stack and scale up, and also onboard them to Azure. So that's my role. Yeah, thank you Vivek for having me. So who's our guest today?
Perfect. So we are going to have a very interesting person, Dr. Rimjhim here. And I was just chatting with her. I know she is living a dream, engineering dream. Just before this show started, right? I was just talking to her like, yeah, you did engineering in bioinformatics, and then MTech in biotechnology, and then PhD in the same field. um, Most of our engineering folks, students, don't follow that, right? If they are in different engineering, they change streams and become computer science engineers, or become more into do masters in different streams. So which is really good. It's a story which all youngsters should look into. If you're a young person who you're looking into the show, you should learn from Dr. Imjin here. So welcome, Dr. Imjin, for the show, the Scale Up Thursday show. This is our fourth episode, and we have been talking about different startups and understanding how they build, and how they are, what's been their journey in building, not just building the startup, but also their technical journey, right? So technology wise as well. So welcome to the show, and please introduce yourself. I did a formal introduction, but yeah.
Thank you so much for having me here. Hi, everyone. And this is a really good opportunity that I'm uh, here to speak with all of you. So I'm really glad that we can do this. And thanks to you people for giving me the opportunity to talk.
Yep. And today we are going to discuss about how to build a medical startup, right? And let me bring up your slides here. S- Yep. So all yours, Rimjim. So we are here to learn from you.
Thank you so much.
Yeah,
And
so
I will, yeah, please go ahead.
so tell us a little bit maybe about yourself and maybe the problem space you're solving, and we can take it on from there.
Sure, sure. Please feel free to have the discussion, interrupt me in between. That is not at all a problem. I would like to answer as much question as I can. And yeah, let's quickly dig into this. So, majorly, we are solving the lack of information in the neuroscience, or I can say any brain-related disorders. Right now, doctors are having a lot of structural information where they can see tumor or they can see tracks, but that too is not in a good resolution. They are lacking the functional information to perform any surgery or to do the treatment or to for any neurological as well as psychiatric disorders. And also For neurosurgery cases like glioma, tumor, epilepsy, for all these, they lack the functional information. Some of the very tertiary hospitals like NIMHANS and some like Data Memorial, these people are having some of the functional information using task-based fMRI. But other hospitals, they completely lack it. That is what we are trying to solve. We are trying to get more and more information from other neuroimaging modalities as well. That's why the major problem that neurosurgeons face is after surgery, patient might lose the ability to speak or to walk or even cognitive functions like performing basic tasks and understanding what is being told to them. Such critical functions are lost. In neurological conditions like Alzheimer's, the therapies are not very targeted. So if we have more functional information, the therapies will be more targeted and the medicines will be more targeted. Similarly, in psychiatry, most of the psychiatric disorders are functional disorder, but we are completely lacking the functional information over there. And to make this available to doctors, usually there is a neuroradiologist in the team who is sitting and deciphering all this, which is still a very high intensive task because we use technology. We need to use technology over here. It is a multidimensional problem and it is not very intuitive to humans only. And that's why the biggest reason behind that all these information is not available. Brain is exactly like universe. A lot is very complex. You can see how staggeringly similar these two images are. One is universe, one is brain. And you can see that one is in nanoscale, whereas another one is in light years. Though these are in different scales, but there is a lot of similarities and complexity associated with it. When we are dealing with such a huge complexity, we need to have good technology on top of it to get the information done. And the second reason is we
Uh,
do have
uh,
some, yeah,
Jim, yeah, sorry to interrupt. So quickly, I wanted to kind of, take a step back and, you mentioned MRIs, right? So for
yeah.
our audience, maybe many of us, including me, don't have a medical degree. So what is it that you see in an MRI, right? If you can maybe take a step back, like what is it that you're measuring? What is it that you're seeing? Maybe if you can just give a brief overview of what it contains, that would really help us. And yeah, if you're covering that later, please let me know,
Yes.
that you'll cover it later.
Yes, I will just mention one more problem that we are facing about data. We do have data in medical imaging, like there is structural MRI, functional MRI, DTI, PET scanning. There is so much of data lying out there. But data to information is also a pathway which is very intensive. I would say it requires because it is 4D data set. 4D data set is time series data, which is 3D. Right, so it requires a lot of processing and munching, which is not being done just by radiologists. It is very difficult. We do have general radiologists, 10,000 in the country, which is still very less in number. And neuroradiologists are still very small in number. We don't even know exactly how many we have, but it is estimated it is somewhere between 30 to 300, which is extremely small number of neuroradiologists in the country. And it is not just neuroradiologists, neuroradiological researchers are also required who can bring in the innovation to get such information. Right? I will walk you through how the data looks like. There are three types of data sets: structural, functional, and DMRI that we are dealing with. We are getting the structural information from structural MRI, functional information from functional MRI, and the uh, fiber information of brain from DTI. Now you can compare it with a Google map. You have destinations, you have road maps, and then you have traffic maps. What right now is lacking is the traffic map, which will make you delayed, which will make you wonder where you are moving and stuck in traffic if it is Bangalore. Right. Similarly, if you don't have information of traffic or the function in brain, it can be very difficult for doctors to deal with. So we are bringing all these three informations together along with visualization using machine learning to get much quicker, deeper, and richer insights into the brain. That's why we call it advanced neuroimaging, and this can help in diagnosis, management, and rehabilitation. Just to give you an overview, this
So,
is,
so I have a
yeah.
I have one question here. So basically, you're trying to solve a problem which is after the surgery, on a specific problem. So after surgery, we want to know where exactly there could be a chances of something going wrong.
No, no, it is not just after the surgery. Let's say somebody came into a hospital with headache. Doctors say that there is a tumor. In the first instance, when they go through neuroimaging, they saw a tumor being there. Then they want to perform the surgery. This is pre-surgical planning itself. They can do using this platform. So one part, they can do pre-surgical planning. So they will see where the tumor is. Near the tumor, what all functions are there, which can get impacted when they are performing the surgery. If it is a language region and tumor is very nearby the language region, it is required for them to understand in much detail how much they can extract the tumor. They cannot extract the full tumor if it is very close by, because they will be hampering a very critical function. But they would want to take away all the tumor as well to extend the quality of life. So it is about the benefit risk ratio. They can see using this technology and they can then take a decision if they want to extract the complete tumor. It is not at all harmful for the function, or vice versa.
Then how it is used after the surgery?
After the surgery, once the tumor is extracted, sometimes it is relapse of the tumor and a patient needs to go for another surgery. In that case, also it can be used. Another way is rehabilitation. Let's say if the function was very nearby the tumor and while resecting there has been an impact, that information is also needed. If there has been an impact in the function, then it can also be seen in the imaging and the reports that we are giving, and again the action can be taken accordingly. So for rehabilitation also it is very helpful. They will also know what kind of function is impacted, like if it is language function which is impacted or it is cognitive function if it is impacted, then they can target the therapies accordingly. They can do more cognitive therapy instead of language therapies. So in rehabilitation also it is useful.
Got it. Thank you. Thank you for explaining that process.
Yes. So these are the major three modalities, and DMRI, structural MRI, and functional MRI. The data, like I said, is very complex. We are trying to get as much of information. For structural MRI, it takes around 10 minutes, which doctors are already doing in the MRI machine right now with all the patients. For functional MRI, we take extra 7 minutes because this is not a usual imaging modality that is being taken. This is what gives us the maximum amount of information of the function. This is called as resting state functional MRI. Now the patient goes inside the MRI machine, just lie there for extra 7 minutes, and it is a kind of video of the brain which is being captured. Usually, when it is being captured, all these reds and blues that you are seeing here, it won't be there. It will be a plain image, and that is a plain video that is being captured over 7 minutes of time period. And then there is DMRI, which is the fiber information. You can call it as a roadmap of the brain, which is being captured. Again, the colors that you are seeing won't be there. It will be a plain image. After processing, we extract all these information and color code it where they can see the colors in the images. That's why there are three levels of macro information that we are at present extracting. One is the structural, where we will be able to exactly color code and extract the area of the brain which is under study. Then there will be tracts of the brain and then functional region of the brain. This is how it looks like when a person is going into MRI. The structural MRI looks like this. It has a lot of information of what we call as the destinations or region of interest in the brain. The resolution will be very high for structural MRI, And in case of functional MRI, it is just a grayscale image. It is like how the TV used to go bad and it will be gray and white. It will just look like that. And it will be around 150 to 160 time points because it is a video. So we talk about it in terms of time points. And even after processing, it will look like this, which is non-interpretable by humans. So one major crucial step of here is denoising and processing of the images. Now, functional MRI is highly prone to noises because in the MRI, person is just resting and they are not performing anything. There are many outside the body noises as well as the noises associated with MRI itself. So the processing of functional MRI is very intensive. It requires around 24 steps of denoising, and for structural MRI, it is around 10 steps of denoising. Then this is DMRI, which is giving us the roadmap where we can see all the tracks and details using the diffusion of water in the brain. So collecting all these three, we do the processing and we divide the whole process into four segments. One is the data cleaning, which I told you about denoising. Then the extraction of the signal. Once all the denoising has happened, it is required to capture the signals. Now we capture the signals according to the frequency. We call this band pass filtering, and that helps us in coming to the exact signals we require to scrutinize. After which we use these signals to do several inferencing. It could be machine learning inferencing or a statistical inferencing. We have several models on top of it where we are, um, depending on the use case, we are doing several processing using machine learning. And finally, it is how we are visualizing it and how we are giving it to doctors to visualize. So we are trying to create a 3D system. Right now, we are giving the images how they are usually very accustomed to look at it in the viewer, which is again 3D, but translating all the 2D information into 3D also is the last step of this process.
So how many data points you might need to build something like this?
So it depends on different part of this. Like for processing, now we have processed more than 1500 files in functional MRI. Now, if you will think about it, 1500 into so many 300, three slices for each into the time points. It is a huge data set of functional MRI if we are thinking about that. And if we talk about the structural MRI, it is much more in number. So it depends on which modality we are taking. Yes, it requires a lot of data set, but a lot in medical data set is different than a lot in computer vision. Like if it is computer vision, you will be looking into the images, which is in lakhs. However, when we are looking into something like this, lakhs, it is not possible to get 1 lakh subjects to give us this much data set. So mostly the information that we have right now is from around 1500 to 2000 subjects. And then we divide it into several different sets for data cleaning. And for machine learning algorithms, it is running for skull stripping. We have thousands of images for skull stripping. It depends on what exactly we are looking for in the use case for machine learning.
Interesting. So in the last slide, I think you mentioned there was 4D. So I'm assuming that it's like the three physical dimension plus time is the fourth dimension, right?
Yes, yes.
Okay. Yeah, this is actually quite involved. Yeah, I mean, this is fascinating because I think as engineers, we never, I mean, in some sense, we take our brain for granted, but understanding the different parts of the brain and also how you're kind of translating in not just of imaging, but how you're kind of denoising it. It's definitely very interesting, right? And then I remember some of my engineering days where we talked about this low pass and high pass band filter. So it's also using a lot of digital signal processing and image processing, which is actually quite unusual in even in machine learning flows. I think it's probably in the medical field and other like manufacturing fields is where we see something very similar, where it is like in obviously in manufacturing it's like more like fault detection, but here also it is fault detection, but in a very very different context, possibly.
Yeah.
But yeah, definitely fascinating. Yeah, so maybe we would maybe want to talk a little bit about the the process in terms of the architecture, if you have that on one of the slides. Yeah.
Sure, sure. We can talk about this completely. So, I am a person who works majorly in neuroscience and machine learning and neuroimaging. I will try to give you as much as information possible on the cloud structure as well. And yeah, so this is our overall cloud platform. We are using all the components from Azure as of now, because we were part of Azure Microsoft Accenture Accelerator Amplify, and they have helped us to, like, they were also guiding us to come up with a lot of challenges and how to solve those challenges. And with all the support of Microsoft and Accenture Amplify, we were able to get to this architecture. We have two-person in the team who are also looking into this constantly, trying to make it better. Now, the different components over here are, first, we are a regulatory compliant company because we are in medical care, and that's why we should get the data set from a compliant UI, which is Medidata for us. Medidata is getting us clinical data set, and our UI right now is compliant because of Medidata. Medidata gives the UI in which you can put exact anonymization and the details where we don't see any patient details. And similarly, we have another collaboration with Carpal. So our front end usually is a third party like that. And then we get the data where we are doing the file processing. Then there is, we are using it in pods. Then there is Kubernetes, which helps us in orchestrating all the services. And it is going into queue. Now, depending on what kind of service we are doing, like for example, changing the Nifty file conversion into DICOM file. Now, these are all the formats of the images that we are getting from MRI. Maximum used format across the world is DICOM image, but for analyzing, we need to convert it into another format called as Nifty. Because all the libraries that are out there, plus the libraries that we are building, all uses Nifty format. So we have a service which converts the file format. Then there are fMRI services, the SMRI services, DMRI services, and this is network mapping. The final results that we see are of network mapping. So it then hits to this particular pod. And tumor segmentation. Whenever we are getting the use case where there is tumor, the tumor segmentation also happens because doctor needs to know how distant a function is from the tumor, and we want to calculate the different distance between the 2 points. And tumor segmentation happens, and then there are output queues, which are, finally it gets saved into the blob in Azure, and we generate the link to it. That link is given back to the users, and it also gets appear in the dashboard so that they can click and view all the results which are there. We can come
Cool.
back to the cloud again. Yes, please go ahead with your question.
Yeah, I have two questions. Yeah. So one is obviously, um, uh, you probably have API integration to get both the data and give the link. So how long does this typical process take? Say once I actually pull the data from Medidata or the other UI, how long does this processing take? And also that was the first question. And maybe the second question is like you have written these various services. What kind of language and what kind of framework are you using for that?
Yes. So one, it depends on the type of data that we are analyzing. So for example, if a use case comes, that is what we are doing in very initially here when we are doing the file processing and other services over here, we get to know if this is just, so we get to know whether this is a glioma use case, or we get to know whether this is Alzheimer's use case. And depending on that, the pods are triggered. Now, if it is just DMRI and structural MRI, it takes 40 minutes to process and give all the information. If it is along with functional MRI, it might take slightly more, around 1 hour, for us to generate all the reports on the cloud. However, right now there are some manual intervention with doctors, since we are working with 20 hospitals now, and we are still coming out of our MVP stage to building all the features that doctors are requiring. We do have a manual intervention at the end where we discuss the details, and doctors also need to understand how the reports are right now given to them. So that small intervention happens at the end of it, which takes, according to doctors' time, it takes some time for us. So we actually tell that we will give you back the report in 1 day.
Interesting. And what languages and frameworks do you use for these services? Like,
So machine learning, all the codes are in Python. APIs are in Java, and front end, some of the component of front ends are in Angular. And yes, that's pretty much it.
There is a
cool.
similar question
And what are,
in the
Yeah.
chat, basically, so which is related to this, so I just want to bring that up. So basically the question is on the data sets, so where it is hosted, it is in local or on-prem. I think you answered that, but again, I just want to make sure it is clear to the
Yeah.
audience.
It is not on-prem as of now. I will actually deal with that question in much more details. We are facing some problems, which is like some challenges are there based on non-on-prem because doctors are slightly wary of uploading the data just like that on any cloud platform. I will go through how we are dealing it in the next few slides. Yes, so this is another slide which talks about we are how we are showing the pre-surgical planning results. Um, so the green, red, blue, green is the motor area, blue is the language area, red is the visual area. How it is uploaded is over here. They can just select the DICOM folder, upload it, and this will be the dashboard. The dashboard will have patient ID. There will be name which will be appearing to the specific logins, age, all the other metadata related to the patient, and what files they have uploaded. So there is possibility of uploading all these new imaging files, and all these gets processed and give them really holistic information. If, let's say, they are not uploading one or two of this, let's say they have not uploaded resting state, then at least we will process these and give them information about rest of others. Or if they are missing out on DTI, then we will process resting state and structural and give the information accordingly. This is how the results look like if it is DMRI, which is the roadmap. It is one of the very important fibers in the brain. You can see if there is tumor here, doctors can see how the fibers are moving next to the tumor. This is real image of a real patient came to us for processing. You can see here there is a mild deformity, and the lesion is having language region very nearby, and these are usually scrollable image. They can go in and out. I will show you in the report how it looks like when it is dynamic. This particular screen is a wireframe. Like, this is a roadmap for us because we want to have all these features in our dashboard later. We are building towards it, where we will have all the specific features of optic radiation. These are all the tractography specific details, and these will be embedded in our dashboard. It is a roadmap for us. We are going to build this next. At present, the report that we are showing to doctors are these. Let me zoom in a bit. So the first page, usually the report is 14 to 17 pages. The first page is a general information of the patient. This is a PDF dynamic report which doctors can use just before their surgery on their mobile as well. And it is dynamic because we are embedding videos in the reports, and they can pause at any point of time and see how close the functional area is with the tumor. And yeah, another thing which is very important is laterality. So if a person is left lateralized or right lateralized, which means if I'm talking, I'm using left side of my brain, so I'm left lateralized for language. And if my tumor is in the right side of the brain, it is not going to hamper. So they need to know how much a person is left lateralized or right lateralized. If they are bilateral, then there is possibility of hampering the language of the person. So this kind of laterality index help them to understand if they can extract the tumor in from the left hemisphere or right hemisphere without any difficulty.
So I had a question around this, and I think some of the literature that I've read, and I might be completely wrong here, is if there is any issue with the brain, what I read is uh, maybe some other part of the brain. As I said, the left hemisphere or the right hemisphere can take over. Is it like in a normal person, it's kind of equally divided, or even in a normal person, you can have like a left or right kind of bias? How does that work?
Yes, so that is known as neuroplasticity. Now, sometimes if left is not working fine, slowly right can take over it. But it is not 100% that it will be possible. There are ifs and buts associated with it. Now, again, brain is a very complex system. In some people, it will be much more better recovery, and the right hemisphere will be able to compensate for it. We are actually working on some of the algorithm where we can estimate how the right hemisphere or left hemisphere can compensate for whatever functional loss is happening. But that said, neuroplasticity can work differently for different people. And at the moment when doctors are going for neurosurgery, at that point of time, they would require to have some information so that they completely don't take off the functional region of the brain.
Nice. In fact, I was just trying to recollect, some of these things which where I've read, and for the for the people who are viewing this, I think there is this really nice book that is written for the layperson called "Phantoms in the Brain: Human Nature and Architecture of the Mind" by V.S. Ramchandran, which I read and found really fascinating because it explains in a layperson language, maybe how what are the different kind of maybe disorders or challenges that the doctor has seen, and how they relate to the brain. So I would highly recommend it if anybody is interested in what Dr. Rimjhim is probably saying as well.
Mhm. Yes, so this is another, there are many such images embedded in the report, depending on what kind of region it is. This is language region. And here, the green part actually shows how it occurs in the normal person, and red part is the changes that has happened for this person. So doctors can also compare it with a larger population, how it looks like. And yes, there are for I talked about language region first, then there are motor network, sensory motor network, and then there are visual networks, primary, secondary visual network, auditory networks, central executive network. Now, central executive network cannot be given through any other modalities. It can only be possible using resting state modalities, which we are using. And likewise, there are around 9 networks that doctors can see, which is not at all possible to do in any other modality as of now. So resting state gives 9 networks to go through before performing the surgery, which retains the maximum functionality of the person. I will go back to the slides. So any other question on the structure, cloud,
Yeah, so I just
dimension.
wanted to know, what are you using for orchestrating this entire thing, to make sure that, I remember you said that depending on what is like the possible a problem, you trigger different kind of workflows. So how is that, orchestrated? And maybe also talk a little bit about the report generation service, right? I think it's very interesting that you are, I think, generating a PDF file and then you're embedding videos and other things. So how does that kind of work? Because that might be interesting to a lot of other users in different use cases as well.
Yes. So as you can see, this is under future enhancement. We have a report generation. Right now, when the process triggers, the orchestrator takes care of which pod it should trigger and generate the images. Now, the images that are coming out are in two forms. One, it is in the form of tables, and second, it is in the form of masks. So, the area which you were seeing in red and different colors, those are just the mask. It gets overlaid on the structural MRI. The base image that is there is the structural image. On the structural image, we are overlaying all the masks. So once the outputs are here, then there is another pod which we are still working on. So that pod is generating overlapping these two images and putting it one on top of another. And again, there is like orientation correction and the all the three dimensions should be checked. All those things are taken care of, and then on top of it we are putting all the text and tables which are getting generated. Like for literality index we need the number. So after this we have another pod which is triggering the report generation services. In that pod we have this overlap which is going to a viewer. Now we are using MRI Crow GL viewer to overlay these two images on top of each other and to take the video of it. Now this video part right now is happening in all the three directions, the X, Y, Z coordinates, which I just showed how the videos are moving. In all the three coordinates, it moves and the video is captured. And then that is being overlaid on the report. Still, we are making some mistakes on this, which is why some human intervention is in between required to correct those mistakes. However, as soon as this will be ready, we are going to make it end-to-end process. And right now, with this manual intervention, we are giving the reports to doctor.
Got it.
Cool.
There are a couple of questions actually in the chat.
Yes.
So I just want to make sure we take them as well. So there is a question on is your research or white paper or case studies published? And if you have any specific links, if you can share it with us, that will be great. That's what somebody has asked for. And a couple of questions on. Um,
Yes.
s-
So
so
on
the
the
question,
paper,
sure, yeah, go ahead, go ahead.
I will take that first question because we need a lot of validation. Actually, I will go through the validation slide first. We need the validation to do on underlying science, where we need to publish paper, science behind the product and the algorithm. Now, if the processing is correct, we again need to publish paper. Processing of the data set, if it is correct or not, that also metrics that we are considering. Like if we are saying that it is denoising, what is the signal to noise ratio? What is there is some spatial noise ratio. So all these ratios we need to calculate and also publish those details. Inferencing done on the models, the inferencing like if we are saying glioma use cases, which I just showed, those we call it as inferencing. So those validations are also required. Now we are dealing with AI and the medical uh, people, medical segments of the people, they don't understand AI as much as we do. And that's why we need to explain why machine learning is saying anything. That also we need to publish the paper. details of the clinical trials. We are working with 20 hospitals as of now, and all the details in the clinical trial we are publishing as and whenever we get any observation, we are putting it for publication. Then scientific and clinical papers, software features validation, which is a user validation which is required, product validation, market validation, as any other companies or startup will do. So usually in a startup, you will see last three happening, but since we are in very cutting edge plus medical science, these are the added validations that we need to do, and we are publishing for papers for most of it. And
Cool.
yes, I will be
Got it.
happy to share whatever paper details
Yeah, so
we had.
yeah, I just wanted to actually add on one thing, right? Like I think if you read some of the popular press, I think there is this maybe in some sense I would say fear being created that AI is going to replace humans, robots are going to replace humans. But I think Dr. Rimjim, what you kind of nicely have actually showed us is that it's not necessary to replace humans, but actually humans and computers can work really together to augment what we already kind of know, or like kind of enhance, right, in that sense. So that is like fascinating, right? So how you're working with the doctors, there is also a human in the loop, especially because this is concerning humans, and especially something as complex like probably like the brain or the heart, where even medical research is happening in those areas, and those parts are not completely understood as well. How that interface kind of works is like, especially for the layperson, for somebody like me or Vivek, is like very fascinating, because this is one aspect. Like we typically go to the doctor when something doesn't kind of work right, or we are not feeling well.
Hmm.
But I think the thought process around actually augmenting how doctors kind of work, and how medical research can be kind of in some sense translated into cutting edge machine learning is actually very fascinating for us, and especially the augmentation part with uh, like, because one of my questions was also like going to be like, when you're comparing, say, what parts of the brains are functioning well or not, and I think you answered it to some extent. What is like the baseline, right? Because sometimes even establishing a baseline is also not an easy task, because there's so much variance in the human brain, just as there is variation in all of us to some extent, right?
Absolutely. Absolutely. I completely agree. One, there is no possibility that we can replace doctors. This is just to augment doctors. Final decisions are taken by doctors themselves, and they might still discard some of the decisions that are being made by a tool, and very rightly so, because they are the person who are actually looking at the circumstances of the patient and other details which we are missing out on. We deal with only a specific set of data. We cannot include all the variabilities. Still, there is 40 to 50% of impact on any disorder of the environment. We cannot analyze anything from the environment and include it over here until we have those variables captured, and which is very difficult to capture. So it is not possible to replace any of the doctors. It is always helpful to augment them. Now, doctors in India specifically, given such a huge population, they are seeing hundreds of patients. Like a psychiatrist in India would be seeing 100 to 120 patients in a day. However, in US, when there is enough number of psychiatrists, they are seeing 20 to 30 patients in a day. How overworked are Indian doctors? And I think a technology like that, this can help them in understanding the functional details much more faster instead of going through several iteration with the patients. So this is just to augment them and not to replace them, as you rightly said. And yes,
Vivek, you had another question on the screen, right? So do you want to
Yeah.
bring that up?
Yeah. So the question is, basically this technology is used to identify mild cognitive impairity or impairment,
yes,
or
I was
early
actually
signs
about
of
to talk.
symptoms.
I was
Yeah.
also about to talk about another
Yeah.
use case. So this first use case I told you about was in surgery. Now it can be used for epilepsy as well, because it is also a surgical use case, and traumatic brain injury. So those are all the neurosurgical cases. Another set of use cases are in neurological disorder and psychiatric disorder as well. One example of neurological disorder is dementia itself, which a huge population is going to deal with coming soon. And the major problem over there is to have a differential diagnosis of whether it is mild cognitive impairment or it is Alzheimer's or frontotemporal dementia. One of our projects which is going on right now is to distinguish between the frontotemporal dementia and Alzheimer's disease. And for that, we are using this kind of architecture where we are doing parcellation of the brain, then concatenating all the details of from different parcellation, which gives us a very huge multidimensional data set, and then we reduce it using PCA, then logistic regression. This is an ensemble model of logistic regression and support vector machine, which is stacked over each other, and that gives us whether this person has mild Alzheimer's or it is normal and just having mild cognitive impairment. This is another project that is running right now, which we have not deployed in several hospitals because here we require a larger data set, and there are several difficulties in the data set over here because right now doctors are not getting patients immediately when they are suffering from mild cognitive impairment. People usually reach out to them once it is in severe stages. So the data recruitment itself is a larger problem over here. We are trying to solve it through several of our programs. Like there is Kokoro, where we do recruitment of the patients using our programs. So that is more of a community effort that we are putting in this particular project. And again, since it is more on the functional end, we also want to explain it much better to doctors as well. These are some of the ways how we explain them, all the features that have concluded why this person is classifying as Alzheimer's and not as a mild cognitive or healthy person. Yeah, so this is another use case that we are working with, but this is not near commercialization as of now. This is mm, a research project which will come out of R&D after 1.5 years.
So, Dr. Rimjin, I'd want to talk a little bit about the. You touched upon this a little bit, but I want to talk about the process of validation. Let's say you talked about dementia. Let's say if you want to talk about say Alzheimer's or Parkinson's or any of the other issues, how do you start off with a hypothesis? Like that what you have seen from your personal experience or talking to doctors, and how do you kind of in some sense I would say productize it, and how do you kind of build a different layer? So like what is like a typical thought process? What is a typical product process that you go through? Can you talk a little
Yeah.
bit about
Sure, sure. So we actually first started from psychiatry because my expertise were in psychiatry. My PhD was in psychiatry for machine learning for psychiatry, and that is where we started. However, we saw that neuroimaging is not very oftenly used in psychiatric disorders, and that became a bottleneck to because it was a behavior change. Psychiatrists will also need to send uh, all their patients for neuroimaging, which was slightly difficult. In that case, what we found that Alzheimer's has more patients who are going for the imaging modalities. And that's why we started looking into Alzheimer's. But however, there are early stage capturing difficulty in the case of Alzheimer's. That's why we thought of solving this. Parallelly, we started getting requests from the neurosurgeon who are in the same hospitals. And we started working with neurosurgeons in parallel. We started doing all the background checks for the science of it because science, we are the people who have to answer about the science. Doctor can just tell us what they require. They told us that they don't have enough information for the surgery and all those problems that I discussed before. And we came back with those problems. We sat and we did all the background science for it. We have in-house research team of 4 to 5 people who are looking into the science day in and day out. They look into all the major use cases that we can deal with and what would be the requirement for that use case. So those details are thrashed out. Then it is iterative process. We go back with those information and talk to all the stakeholders, all the advisors, and give their points. And come back and work out it again and go back to the hospitals again. We reach a particular part where it is enough understood. We also check for the technology feasibility. Then it goes to the technology team. We put in experimentations to do the pilots to understand, or do a POC and see if it is feasible to uh, do this particular use case using any technology that we are having. With this, we go back to the doctors and show them the results. If they say yes, we go back and like start building it in the product. In terms of validation, how we do it is again collaborating with the same set of hospitals. They give us data, same set, or depending on the use cases, different set of hospitals. So, for example, if it is uh, the use case of uh, glioma, then we need around 60 to 50 patients from each hospital to see if it is what we are giving and what they expected to result expected. Is it similar, or there are some specific scientific techniques that can help in validation? We put in those techniques for some X number of patients to do the validation, and then we publish it. After publication, if we need to also show the replication of it or the generalizability. That's why we try to do it on a larger population, or in different parts of India or in the world, to give the exact validation that this is a replication study, or this is the baseline validation study. And likewise, we repeat the process with all our use cases.
Okay. Do you have any hospitals that you're working outside of India right now?
So for outside India, no. Right now, we are not working outside the India. However, we are, because one regulatory compliance which is required is, even for
Right.
research, we need FDA research compliances, which we are in the process of fulfilling all the requirements. We are in talks with around 5 different institutions and hospitals in US, and once that clearance has happened, we will trigger all the research work and the pilot work over there.
Cool. Vivek, are there? This is really good. Vivek, are there any other questions in the chat right now?
Yes, there is a question on monitoring dashboard, which tool you're using, but I'm not sure which monitoring he's referring to. Probably the one which you showed uh, in the dashboard where you were showing the monitoring stuff. I think that is something which in the demo, I think, not sure. Look, so Tarun, if you can share like where exactly you were looking for, we can talk more about it. But then
Yeah,
until
so
then,
this
we
is
can just go ahead. Yep.
yeah, this is just a general philosophy of our company to be a responsible AI. Now, because we are in technology and it is in medical science, there can be a lot of things that can go wrong. We want to be as much fair as we can with highest data privacy and security, and we want to explain what we are doing at every stage. And that's why we want to create explainable AI. Even in the reports and model, we want to explain as much as we can so that everything is very clear. And validation I have already covered. Yeah, one part I wanted to touch upon is, since this is a medical technology on the cloud, what are the challenges that we usually run into? So one is the logistical challenge. Like, it is not that one person needs to go somewhere and upload the data set, but what happens, the MRI, the place where usually MRI is kept in a hospital, is very secluded. It will not receive any network. Most of the hospitals, there will be no network in the area where the MRI machines are kept, because they want to avoid all the interference of all the other signals in the atmosphere. And that is why they cannot upload it immediately to the cloud. And until and unless it is coming to our cloud, it is very difficult to do a lot of processing, like QA/QC. Even to do the QA/QC, we need to understand if this image is correct. Let's say right now a patient is there in MRI machine lying for getting all the MRI details. If he will come out and go away, it will be altogether a tedious task to get the patient again and do the MRI if the images are not correct, or if there is some problem with the quality. And that's why we are creating on-premise tool for doing QA/QC specifically for MRI, and we can keep it in their system, which will not be on the cloud. Once that is done, image they need to retake or it is fine, that will be done on then and there, and then they can upload the MRI later from any other system which is outside the radiology space. Then the second problem we usually face, or I would say third problem that we usually face, is the wariness. Doctors are not comfortable giving all the images on the cloud until and unless we go through a lot of clearances from the hospital. Now, for data sharing, because of which we need a lot of clearance required in the ethical. So, if we want to scale, this can become a huge problem. Right now, still we are in all the validation stage. So, scaling from 10 to 20, 20 to 30 is not a problem. But when we want to scale on the cloud, ethical clearance can become a bottleneck, because if they are sharing the data outside the hospital, they need to, we need to go with them for ethical clearance where we are presenting, okay, we are doing these 10 things, and this is not going to, we are not going to use data in XYZ way, or we are going to use data in XYZ way. These all things we need to tell it to hospital, which becomes a fairly long process for us to go for ethical clearance and also the data clearance. And the last problem that we find is regulatory clearance, which is again associated with the data when it is coming to cloud. So for regulatory clearance, we need to show where we are saving the data. That is anyways there even in on-premise. But if it would be on-premise, it will be a shorter process because we will be sharing data, saving data on the same system in the hospital. But when it is coming out of from the hospital premises, there are a lot of regulatory compliances which we need to keep in place on the cloud. So, given that there are so many challenges, and these challenges are not just one line challenge, it actually has a lot of cascade reaction in the background. So, until and unless a company is very sure that they need all the data to do the processing in the background and get to a better result, I think the cloud solution can be very tedious because of these.
So there is one question which is, I think we've been answered this. Where is the patient data coming from? So obviously it's coming from the hospital, and you're taking it from the meta. There is one service where you're accessing this data, so you really don't know which patient actually, right?
Yes. We have a system in the phase when we are in all these regulatory compliance stage of collecting the clinical data for FDA clearance. We have Medidata in place, which does the anonymization part for us, and we get anonymized data only, and it goes to our cloud and server for getting into that processing pod and inferencing pods. So all the data
Got it.
are from diagnostics.
Yeah, just for audience, you keep posting your questions in the chat, uh, so that we can answer those questions. Yeah, go ahead, Dr. Rimji.
So these are the major regulations that we need to go through: ISO, CDSCO, CTRI. I have not mentioned over here, but CTRI is for all the clinical trials, which we need to show it to the hospitals for getting ethical clearances. FDA, GE, HIPAA compliance, and other medical compliances, which we are right now in the process of getting the certifications. And yeah, we are actually now 23 people team, not 19. I and Lina started this company in 2019. My background is in bioinformatics, biotechnology. Then I started working in neurosciences. Few of my paper are in cell signaling, which is microbiology. And then I started working very deeply into the imaging. My PhD was in understanding all the functional MRI, structural MRI, DMRI images using machine learning on top of it to make conclusive predictions for psychiatric disorders, like finding out pattern to do the diagnosis or to understand the progression of the psychiatric disorders. That is where I started understanding more about these imaging modalities and how it can be used for several diseases. I was working predominantly in schizophrenia and obsessive compulsive disorder, after which I started working in a startup which was again looking into Alzheimer's. And then after that, I started working in my own company. Like we founded this a company. Whereas Lina has a background of first as a software engineer, then she did her MBA in healthcare. She has worked in a lot of very prestigious firms. She has done her MBA from ISB, after which she was working with uh, the government for vaccination and healthcare. And then we started working together in 2019. And I also wanted to talk about several accelerators and like Amplify, which because of which I'm here, Edison and several other accelerator who backed us up. We have two rounds of funding already. One was pre-seed round, which was done by Entrepreneur First, and later we had a seed round, and we have several grants and non-dilutive funds from BIRAC funds and also several government funds. This is our great team. We have ML engineers, DevOps, product head, then backend engineers. We have research team comprising of people who are constantly looking into all the scientific details, clinical trials, and we have regulatory person. We have other engineers in ML. So ML, neuroimaging, data science, they are the maximum in number, and rest are. Thank you.
Cool.
Is there any other question that we can take?
Yeah, I had a question, right? So, first of all, I think if you look at the software engineering profession, or I think computer science in general, I think there's a large predominance of I think the ratio gender ratio is actually very skewed. I think, right? Not probably not so much in the medical profession, but definitely I think your startup is at the intersection of maybe say computer science and medical profession. So, did you face any issues, maybe say setting up the team, talking to investors, getting your customers? Did it help you, or did you feel that there were sometimes barriers in actually in each of these three stakeholders, customers, investors, and hiring the team as well?
So, in terms of hiring the team, yes, there are many people very gender biased. Like we can see a larger number of people who are ML engineer who are male. In the coding team, we have fewer female as compared to the team in research. Research and medical team are having equal ratio. But yes, in coding, there is that difficulty. We try to balance this as much as we can. However, the major difficulty we found was getting people who can understand neuroimaging and perform ML on top of it. So that was a huge difficulty. Even in case of signal processing, signal processing can be one way how a person can get into the MRI processing as well. That is where we found difficulty. There were very less number of profile to go through. But that said, if there are any people who are in the overlap between these two, they are usually really great. I mean, uh, two, three profiles that we found at the intersection of these two, they all were really good and we could get them on board ASAP. Um, that took us a longer time to get all those kind of engineer. The second problem that we found was since it is medical technology, also very research oriented medical technology. So yes, we need to explain to investor much more. And sorry, excuse me. And to investor, we also need to um, say that we have a longer cycle of reaching to market, which is slightly challenging for investors to invest if they are looking for immediate huge market. Then it becomes slightly difficult because we have a lot of regulations and compliances to do and a lot of clearance that we need to take, which adds up to our overall cycle to reach to market a longer time. So getting those kind of investors is difficult.
Yeah, absolutely. I think you need investors who not only give you money but also have connections and understand the field well, because it is maybe not like a e-commerce product or like a consumer product, it I think the upfront investment is high. I think there's a lot of upfront work. But I think the flip side of it, as you rightly said, I think once you have kind of figured that part out, then I think, and you are compliant, like as and you mentioned, you're compliant, then I think that getting that adoption actually becomes much easier, because then you have more, because of the upfront investment that you have done. I think it becomes in some sense hard to compete with you, because every other competitor that comes with you has to kind of do that entire journey again. That's where I think you kind
Mhm.
of build up that moat as well.
Yes,
Cool.
absolutely.
Yeah. Vivek, do you have any other questions, or are there any other questions from the chat? I realize we're just over time. And also, Dr. Rimjin, are there any other aspects that you want to cover as well?
No, that's it. I think this itself is a lot of information for people to understand and go
Yeah,
through. I would be happy to, if they want to connect with me over LinkedIn, and if they want any answer, I would be happy to help the startup community.
yeah. It basically took me to another world actually. Like I'm just thinking like how to build such a product. Like it's so so difficult. You need to understand deep understanding of the the field, and understand technology and how to use the technology, and you're doing it right as well. If you see that the architecture, it is in within the VNet, and it is part of Kubernetes, and you have pods being built, and you're using all the things right. And that's the interesting part of it, right? So like I'm just thinking like, wow, this is really different, and going in depth into that specific area is very very much needed, right? Very
Yes,
interesting. And thank you for being on the show. I think this was a really an interesting discussion, and it took us to a very different world. And
thank you.
we can wait for a minute or so. If
Yeah.
there are any questions from the audience, we can take those questions. But yeah, no questions from my side. Probably I'll go back and explore a lot of things about this now.
Yeah, I think yeah, there's a lot of, in some sense, food for thought, and I think this was, as we said, a fascinating, very different world for us as well. And as I said earlier as well, I think we I think normally we don't think about the medical field as much until we have some issue, and then we like go back and talk to doctors. And I'm very thankful that like so many doctors actually spend so much time understanding these parts. And also at the same time also, it's very fascinating how technology is actually augmenting doctors as well. And for those who are not in the medical profession also, I think just as there are advancements in technology, right? Similarly, I think there is advancement in medical science, and it's kind of fascinating that interplay where you talked about the process of how doctors are learning, and how you're learning from doctors, and how technology is helping doctors understand different aspects. So that interplay was also very fascinating for me. So yeah, thank you, Dr. Rimjhim, for like enlightening us to this part of the world. I'm sure that we'll reference this as well in some of the other conversations. And as far as the architecture is concerned, I think me and Vivek are nodding as well, because I think you kind of seem to have like gotten many or pretty much all of the aspects right. Whether it's security, whether it's kind of doing isolation, whether you're thinking about integration. So in fact, we didn't even have to ask questions, because while the questions were popping up, you were answering them as well.
Thank you so much. Pleasure is all mine. And I always love to talk about our company, our work, because I'm passionate about it. So thank you so much for having me here.
Yeah, thank you very much. By the way, for the audience who are here, we were just popping up this all through, but I just want to talk a little bit about this. We have a link for Founders Hub, and you can apply if you have an idea and you want to build a startup. You want to try and you want to meet people. There's mentorship and a lot of other things which is there in the Founders Hub. So there is a link there, and you can reference the email ID, which is scaleupthursday@microsoft.com, which is our show name. So you can use that so that we can get back to you pretty fast. So that's one thing. And the other thing is interesting is we have an amazing Microsoft Learn module on building your own startup. So there's bunch of stages of startup, right? How do you pitch? how do you raise funds, and how do you come up with the market. Everything is listed out there, so just go back and take it, take time and read through it. That is something which is very interesting learn module out there. So as we have come to the closing of this episode, there are no more questions. So thank you, Dr. Rimjhim. Thank you, Vinayak, for being here. Thank you, Rashmita, for hosting us. Thanks all. See you next session, which is on 22nd. 22nd or 23rd? 22nd. It's
24,
on the
20,
Microsoft.
yeah,
24th.
it's on.
I got everything wrong. Okay, it's on 24th. So let's meet on 24th on the next episode. Okay. Take care. Bye bye.
Bye.
Thanks.